Hi everyone, in this video we're going to look at how to play in Google Spreadsheets with our data and get Google Spreadsheets to calculate for us the b-value for our exponential curve that we're working on here for Vlad's SoundCloud data. And so what you'll need for this is you'll need to get to Google Classroom, which you can do up in this right-hand corner. And so you have your Gmail, your Google Drive, and you have Google Classroom here. So go ahead and click Google Classroom, and then you'll want to find Algebra 2. If you're not in Algebra 2 yet, here is our class code that you can join on. So make sure to add that, and then you'll be enrolled in our Algebra 2 course. Under our classwork, we can see that we start to have a project, our exponential model, and you have your own data collection to play around with right here. So you're going to click on that data collection and open it up. And so in here, you can see that I've collected our data of Vlad's song titles from SoundCloud, their rank and popularity, and their number of listens. And this matches the Desmos data that we put in on the first day of looking at this. One of the things I'll want to do right away with my source is remind myself where I found it. And so way over to the side, maybe over here, we're going to put our source, and we're going to put in where we found this. So this was SoundCloud, Quack, and it was under top tracks. So I'm going to click on top tracks. That's where we got our data. And I'm going to highlight this and paste it into our spreadsheet. So that's one thing you'll want to do when working with data. And then I also could link to Desmos, our Desmos graph, so I can have easy access to that. Share in the upper right hand corner. Remember, log in, and then you can find your model. It's saved under this menu over here. And then you can find your saved data from that first day. When you open it, you can click share, and then we can put that into our spreadsheet. So now you can remind yourself where you found the data and also where you have your visual of this data. The next thing we can do is manipulate spreadsheets. And so in order to get all of these to look nice, so we can see the whole thing, you can hover over the line separating A and B, and you can double click when you have that black arrow, and it will automatically adjust. Another thing to do is you can press on the letter A, and then press Shift and click on the letter C, and then just do it for all the columns at once by double clicking right there. So that will automatically adjust. We're looking for that black arrow and double clicking. Another thing you can do is this is our data, and these are our song titles. So I'm just going to highlight these a little bit in a different color. I'm going to change those to gray. And then one other thing that you can do to present your data in a good way is either to bold or change the text size of the first one with this bold button right here. So what we want to do next is we want to tell Google Spreadsheets to calculate the b-value for each of these. So what we did was we calculated this b-value over here, and we did that in class. And I'll remind you over here. So we set our asymptote to 21, a height of 21, because that's what we saw as that leveling off point. And then we used estimated y-intercept at 0.68 right about here to get our a value of 47. And then what we did was we took one of our data points, the easiest one, 5, 32.0, and we substituted that into our building block, our exponential building block, to try to obtain a b-value. But that was only one data point. In order to get a really good fit, we would need to calculate all of the b-values for every single data point and then take an average, so we have something that fits all of our data. So we're going to try to actually tell Google Spreadsheets to do this calculation. But in order to do that, first I need to put my a value to the side, so Google Spreadsheet knows the a value that we're working with, and also my c value to the side, so it knows what we're working with. So my c value I'm setting to 21, and my a value is at 47. Since this is kind of a standalone cell, I'm going to change the border color to black, and maybe change it to a slightly different color so we can see what we're working with. Double click and double click. Okay. So here I'm going to calculate my b value. for each data point. And I'm going to start with this one. So it's really a step-by-step algorithm. In order to tell Google Spreadsheets to calculate something, let me just teach an easy example down here. We start with the equals button. So for instance, if you want to Google Spreadsheets to, for some reason, take the average of all these numbers, we would type in average, and we would calculate those numbers, and it would give us the average of all those numbers. Another way you can use it is for simple math, like if I wanted to take 68.9 and add it to 48.3. So it's taking the number in C2, which you can see here, C2, and it's adding it to C3, and it will calculate that value for us. What we want to do is calculate the B value. So here, we are going to look at what we did over here. So the first thing we did mathematically was we took 21 and we moved it over to this side. So we took 32 minus 21. So in Google Spreadsheets, what I would do is say equals 32 minus our C value of 21. Okay. Then the next thing I did was, let's see, I divided everything by 47, which was our A value. So the next thing I would do in my model over here, because I did this calculation first, I'm going to protect it with parentheses. And then I'm going to say, okay, the next thing we did was I divided everything by 47, which is sitting over here. Okay. I bet you could probably finish this on your own, so try it. I'm just following our step-by-steps, but I'll keep going here. I divided it by 47, and then the last thing I did was I took the fifth root of 11 over 47, so the next calculation I need to do is the fifth root. Okay, so I'm going to protect this because that was the second step I did. And then the last thing I did was take the fifth root. There is no fifth root button on your calculator. However, hopefully by now you've done the Khan Academy work on rational fractional exponents. That was our indie work out of our yellow packet. And it was number 3, rational fractional exponents. And hopefully then you know that taking the square root is the same thing as taking something to the power of 1/2. So if I show you down here an easy example, 4 to the power of 0.5, 1/2 is 2. That's the same thing as the square root of 4. So the cube root would be the same thing as to the power of 1/3, and on and on and on. So the fifth root would be the same thing as to the power of 1/5, or 1 divided by 5, our x value here. And if I press enter, we should get what we got in class, which was 0.748. And I don't. So something went wrong in my algorithm, or it's rounding funny. Oh, there we go. Aha. So in Google Spreadsheets, sometimes it deletes some decimal places. Make sure to press increase decimal places or decrease if you wanted it to be a little more rounded. For some reason, these are showing up funny. And let's make the font size 11. Okay. And now Google Spreadsheets has an algorithm written in here. So it should work if we dragged it all the way down and all the way up, and it should recalculate. So let's drag all the way down and all the way up. And for some reason, it's not working. So I would, if you're a programmer, I would pause and look at what it's doing for the rest of these and why something is going wrong. But let me show you for those of you who are new to Google Spreadsheets. So in here, we had a great calculation, and it took specifically our A value, our C value first, which was F2. So we want it to always subtract F2. And we want it to always divide by F1, our C value and our A value. But in the next one, if I look here, I want this to be 30.9 C7, which it does use, minus F2. But for some reason, it automatically corrected and thought that we wanted to use F3 since it was below, the next one below. And it thought it wanted us to use F2 since it's one row below. So we want to tell Google Spreadsheets that we always want to use F2 and we always want to use F1. So the way that you do that, you could Google how to fix things in Google Spreadsheets if you wanted to solve it on your own. But I have learned that that is done with $ coding. So put a $ in front of the F and a $ in front of the 2 to fix those cells and always use them. $ in front of the F and a $ in front of the 1. I think these two are the only ones we want to fix. The rest of them, we want to use the numbers that are given. So we're going to press enter again on that one. And then we're going to try that again. We're going to hover and drag all the way down. And then hover and drag all the way up. And then we have our B values. Let's actually make it look a little nicer. We'll put that in the border, and let's separate that from the summary table. So we're going to insert a column to the right. There we go. That looks a little better. Let's try to get rid of that border, though. We want borders on both sides, but not. There we go. Oh, I don't know. You can play around. Try to get those borders to look a little more normal. There. And we'll just redo that one. Okay, so now you have your B values. And now what we would want to do is take the average of these, but ignore any outliers. So I see an outlier here of 1.01, and that seems to stick out from the rest of the data. So I'm just kind of going to gray this one as an outlier. And then what I would want to do is take the average of the rest of them. So our average B value would be equals average of all of these data points. And let's double click that so we can see it. And then we have an average B value of 0.750, and that is our whole goal, to get an average B value. And so now you know how to do that algorithm in Desmos. The last thing that you would want to, after you're done finding your algorithm and getting your average B value from Google Spreadsheets, the last thing you would want to do is program it into Desmos and make sure it's a good fit. So we have our model right here, and we have y equals 47 times 0.750 to the power of x plus 21. Here's our C value, here's our A value, and here is our B value obtained in Google Spreadsheets. We can see that it fits our data very nicely. Remember that you could, if you wanted to present data differently, you could change the color in Desmos, whatever you want to do there. And one other thing we can do, just so you know about it, is you can check your model against Desmos regression model. And the way that you type that is you say, please take my y values and approximate them, squiggly line, that's shift, and then the button just to the left of the number 1, and into an exponential model, a times b to the power of x1, my x data points, plus c. And it will give you its own model, and it will tell you how well it fits out of 1. So a perfect model would be 1.0. So you can see their model is pretty good for an exponential model. And neither one of them is correct, but they're just good estimates to try to fit the data. You can see Desmos' model tries to fit this outlier a little better than ours, but I think ours is a really good match for the overall pattern. So both of them can be used for analysis, and you can decide which one fits our data better in your opinion and use that for analysis.